In the last video, we found the zeros of the function f of x equals x cubed minus 5x squared plus 3x plus 4 by finding first the possible rational zeros by dividing the factors of the constant term by the factors of the leading coefficient. Then we substituted these possible zeros into the function f of x to see if they are actual zeros. However, for numbers like 4 and -4, we use synthetic division instead of substitution. After finding out that 4 is a zero of the function because f of 4 equals 0, we reduced the cubic function to a quadratic function to see if we could find more zeros. After seeing that the polynomial can't be factored, we solved the problem with the quadratic formula, which gave us 2 additional irrational zeros. But sometimes when we have polynomials like x cubed plus 3x squared plus x plus 3 or 2x cubed minus 6x squared plus x minus 3 or 3x cubed plus 9x squared minus 2x minus 6, we can factor by grouping instead of going through all these steps. We can check if we can use the grouping method if 3 divided by 1, which is 3, is the same as 3 divided by 1, which is also 3. In the second grouping example, we have to check if -6 divided by 2 is equivalent to -3 divided by 1. Which is obviously equivalent. And in the third example, we have to check if 9 divided by 3 is equivalent to -6 divided by -2. Which is also obviously equivalent. Now, how can we factor by grouping? We factor like we do with regular factoring, but it's like we have 2 different problems. We factor the first group, which is x cubed plus 3x squared, and we factor the second group, which is x plus 3, separately. We can write the first group as x squared times x plus 3 in parentheses, and we can write the second group as 1 times x plus 3 in parentheses. Normally, we don't write the 1 when we do multiplication because 1 times x plus 3 is just x plus 3. But when factoring by grouping, the 1 helps us to factor. We see that x plus 3 is in both terms. So we can write x plus 3 in parentheses times x squared plus 1 in parentheses. The first zero is -3. Because -3 plus 3 equals 0. Let's find out what the other zeros are. So when does x squared plus 1 equal 0? After subtracting 1 from both sides, we get x squared equals -1. Note that when taking the square root, we get a positive and a negative solution. So we get x equals plus minus the square root of -1. The square root of -1 is the imaginary unit I. So we get I and -I as our second and third solution. Let's look at the next example and factor by grouping. Again, we can write the first group as 2x squared times x minus 3 in parentheses plus 1 times x minus 3 in parentheses. So we get x minus 3 in parentheses times 2x squared plus 1 in parentheses. The first 0 is 3. Let's find out what the other zeros are. So when does 2x squared plus 1 equal 0? After subtracting 1 from both sides, we get 2x squared equals -1. And after dividing by 2 on both sides, we get x squared equals -1/2. Now we take the square root from both sides, so we get x equals the positive and negative square root of -1/2. So our second solution is 1 over the square root of 2 times I, and our third solution is the negative of 1 over the square root of 2 times I. Let's look at the last example and factor by grouping. I really encourage you to pause the video and try this on your own. We write the first group as 3x squared times x plus 3 in parentheses minus 2 times x plus 3 in parentheses, which is then x plus 3 in parentheses times 3x squared minus 2 in parentheses. The first 0 is -3. And again, let's find out what the other two zeros are. So let's set 3x squared minus 2 equal to 0. And after adding 2 to both sides of the equation, we get 3x squared equals 2. And after dividing by 3 on both sides, we get x squared equals 2/3. So we get x equals plus minus the square root of 2/3. So x2 is the square root of 2/3 and x3 equals the negative square root of 2/3. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.